Salam and good day everyone. Okay, so for today, we will be going through chapter 8. Okay, systems implementation. So this topic, okay, is the fourth of 5 phases in the SDLC, or known as System Development Life Cycle. So it includes application development, testing, installation, and evaluation. So users will be working with the system, okay, on a day-to-day basis, and you will focus on system operation and support, okay, which is the final phase in the SDLC. Okay, so this is the outline, okay, for this topic, okay. Software quality assurance, application development, coding, testing the system, documentation, training, and lastly, data conversion. Okay, so moving on to the software quality assurance. Okay, to improve the finished product, okay, software system developers should consider software engineering, okay, and internationally recognize the quality standards, okay. So companies are intensely concerned with the quality of their products and services. Okay, so the main objective of quality assurance is to avoid any problems, okay, or to identify the problems, okay, the issues, okay, as soon as possible. Okay, so poor quality can result from inaccurate requirements, design problems, okay, coding errors, faulty documentation, and maybe ineffective testing. Okay. Alright, so for this one, okay, quality is very important. Okay, so you can use an approach called software engineering, okay, for you to manage and improve the quality of the finished system. So software engineering, okay, is a software development process that stresses solid design, accurate documentation, and careful testing. Okay, so Software Engineering Institute, or known as SEI, at Carnegie Mellon University, okay, it is a leader in software engineering, okay, and provides quality standards and suggested procedures for software developers and system analysts. Okay, so they design a set of software development standard, okay, that being used successfully by thousands of organizations around the world, okay, around the globe. So the purpose of the model, okay, capability maturity model, CMM, is to improve software quality, reduce development time, and cut costs. Okay, so recently they established a new model called capability maturity model integration, or known as CMMI. Okay, this new model, okay, integrates software and system development into a much larger framework called process improvement. Okay. Okay, so this is CMMI model, okay, the new one tracks and organization processes using 5 maturity levels, okay, from level 1, referred to as unpredictable, okay, poor control and reactive, to level 5, this one optimizing, okay, in which the optimal result is process improvement. Okay, alright, so Next thing, okay, International Organization for Standardization, or known as ISO. Okay, it is an international body that establishes quality standards for products and services. Okay, including software development also. So ISO states that standards which provide product quality, compatibility, and safety. Okay, so a company can specify ISO standards when it purchases software from a supplier or use ISO guideline for in-house software development to ensure that the final result measures up to ISO standard. Okay, so ISO standard include everything from internationally recognized symbols to the ISBN numbering system that identifies this textbook. Okay, so this is the internationally recognized symbol. Okay, this figure. Okay, so moving on to the application development. Okay, for the application development, okay, it is the process, okay, of constructing the programs and code module that serve as the building blocks of the information system. So structure analysis, OO analysis, and agile method are three popular development options. The objective is to translate the design into program and code modules that will function properly, that will work properly. Okay. Alright. Okay, so for the application development task, okay, so actually building a new system, okay, you will require careful planning. Okay, so after an overall strategy is established, okay, individual modules must be designed, coded, tested, and documented. Okay, so a module will consist of related program code organized into small units, okay, that are easy to understand and maintain. Okay, so after the modules are developed and tested individually, okay, there will be more testing takes place, okay, along with documentation of the entire system as shown in this figure, starting from planning, okay, and then develop this module, okay, and then you need to test. Okay, so there are three type of testing, okay, starting from integration testing and then system testing, okay, and also the unit testing. Okay, so for the application development, okay, there are documentation review. Okay, so this one you will need solid documentation, okay, from prior SDLC phases to design programs and code modules. Okay, so by using the system documentation, okay, as a blueprint, you will develop structure charts that break the system into smaller pieces that programmers can translate into programs and modules. Okay, so for the program design, okay, you must view the system as a series of interactive modules. Okay, so for the top-down design, okay, partitioning until the modular design, okay, you can use project management software, okay, for the program design. And for the structure chart, okay, it will show the program modules and the relationship among them. So for the control module is a higher level module, and subordinate modules is the direct lower level modules. Okay, so let's move to the structure chart. Okay, so structure chart show the program modules and the relationship among them. Okay, so this is an example of structure chart modules. Okay, so a rectangle represent a module. Okay, so vertical lines at the edges of a rectangle indicate that a module is a library module. Okay, as you can see in this figure, so reusable code and can be invoked from more than one point in the chart. Okay, so for the data couple, okay, an arrow with an empty circle here, okay, represent a data couple which shows data that one module passes to another. Okay, this one is the structure chart data couple. Okay, for the control couple, okay, this one is for the control couple. An arrow with a fill circle, okay, represent data couple which shows that data that one module passes to another. Okay, so this is control couple, example of structure chart. And then for the condition, okay, it is aligned with a diamond on one end represent a condition, which indicates that a control module determines which subordinate modules will be invoked. Okay, so depending on a condition. Okay, so this diagram, okay, shows a control module that triggers 3 subordinate modules: sort by part name, sort by part number, and lastly sort by inventory value. Okay, so sort inventory parts here, it is a control module with a condition line, okay, that trigger these 3 subordinate module. Alright, so for the loop, okay, a curved arrow represents a loop which indicates that one or more modules are repeated. Okay, this one, loop, a curved arrow here. Okay, so in this example, okay, shown in this figure, the get student grades and calculate GPA are the modules that are repeated. Okay, this one, these 2 modules, get student grades and calculate GPA. Okay, and then moving on to the cohesion and coupling. Okay, so cohesion measures a module scope and processing characteristic. So a module that performs a single function or task has a high degree of cohesion, which is desirable, okay, because it focuses on a single task and it is easier, okay, to code and reuse. Okay, so if you need to make a module more cohesive, you can split it into separate units. Okay, so each with a single function. Okay, alright, so this one, okay, example of tightly coupled and loosely coupled structure chart. Okay, so coupling describe the degree of interdependence among modules. Okay, so modules that are independent are loosely coupled. Okay, so loosely coupled modules are easier for you to maintain and modify because the logic in one module does not affect other modules. Okay, so tightly coupled modules have one module linked to the internal logic contained in another module. So this one is tightly coupled, this one is loosely coupled. Okay, so moving on to the drawing a structure chart. Okay, here are the steps in the drawing a structure chart. Okay, so you need to follow 4 steps, okay, when you want to create a structure chart. Step 1, you need to review the DFD and object model. Okay, so you need to check for accuracy and completeness, okay, of the first step. Okay, and then second step, you need to identify modules and relationship. Okay, identify the program modules and relationships. Okay, so you will work your way down from the context diagram to the lower level diagram 0. Okay, and then identifying control modules and subordinate module. Okay, until you reach functional primitive. Okay, and third step. Okay, you need to add symbols for couples, conditions, and loops. Okay, like previous example. Okay, so you need to identify first the data elements that pass from one module to another module. Okay, so last step is you need to analyze the structure chart, the DFD, okay, data flow diagrams, and also the data dictionary. Okay, just to ensure that it is consistent with your system documentation. Okay, to ensure that the chart reflects all previous documentation and the logic is correct. Okay, so for the application development, okay, other application development tools, okay, there are program flowchart and also the pseudo code. Okay, so moving on to the coding. Okay, coding, it is the process of turning program logic into specific instructions that the computer system can execute. So working from a specific design, a programmer uses a programming language, okay, to transform program logic into code statement. For example, Visual Basic, Python, Ruby, SQL, okay, are the example of programming languages. Okay, and then for the programming environment, okay, each IT department has its own programming environment and standard, so you need to know that. Okay, to because make it easier to program interactive software product by providing built-in tools, advanced features, okay, such as real-time error detection, highlighted code, and version control. And then for the generating code, you can use application generators, report writers, screen generators, fourth generation languages, okay, and you can generate editable program code directly from macros, keystrokes, or maybe mouse actions. Okay, so for the testing the system, so the first step is to compile the program using a case tool or a language compiler. Okay, so this process will detect syntax error, which are language grammar errors. Okay, so the programmer correct the error until the program executes properly. Okay, so next thing, the programmer dash check the program. Okay, so dash checking is the process of reviewing the program code by programmers to spot logic errors which produce incorrect result. Okay, and then after that, structured walkthrough or code review. Okay, and then design walkthrough. Alright, so here are type of testing. Okay, so for the unit testing, okay, here unit testing means that the testing of an individual program or module. Okay, so test data should contain both correct data, okay, and should test all possible situations that could occur. Okay, so the objective is for you to identify and eliminate execution error. okay, that could cause the program to terminate abnormally. Okay, so the program that interact with other program and files are tested individually, okay, before integrated into the system. So you need to remember the first step in testing is a unit testing, okay, and then followed by integration testing, and lastly system testing. So there are three types, okay, of testing. Okay, so for the, let's take a look, okay, an integration testing. Integration testing is testing two or more programs that depend on each other to make sure that the program work together properly, okay. And then for the last testing is the system testing. So system testing will involve the entire information system after integration testing, okay. So you need to perform a final test of all program, okay, and then you need to verify the system, and then you need to ensure that the IT staff has the documentation and instructions needed to operate the system properly, and then you need to demonstrate that user can interact with the system, okay. After that, you need to verify that all system components are integrated properly. Okay, lastly, you need to confirm, okay, that the information system can handle predicted volume of data. Okay, so for the documentation, okay, it describes an information system and helps the user, manager, and IT staff, okay, who must interact with it. So accurate documentation can reduce system downtime, cut costs, okay, and speed up maintenance tasks. So there are four types of documentation, starting from program documentation, second one system documentation, okay, third one operation documentation, and lastly user documentation. Okay, so for the program documentation, so this documentation, okay, guides programmer who construct module that are well supported by internal and external commands and description that can be understood and maintained easily. Okay, so it will describe the inputs, outputs, and processing logic for all program module. Okay, next one, system documentation. Okay, so system documentation describe the system function and how they are implemented. Okay, so it will include data dictionary entries, data flow diagram, DFD, okay, object models, okay, screen layout, source documents, and the system's requests that initiated the project. Okay, for the operation documentation, okay, it contain all the information needed for processing and distributing online and printed output. So typical operation documentation includes the program, system analyst, programmer, and system identification. Okay, and then scheduling information for printed output. Okay, such as report, run, frequency, and deadlines. Okay, for the operation. And lastly, the user documentation. Okay, it consists of instruction and information to users who will interact with the system and includes the user manual, help screen, and tutorials. Okay. Okay, so this one is a sample page from a user manual. Okay, so there are instruction explain how to add a new task to the system. Okay, so moving on to the training. Okay, next. Okay, training plan. Okay, so the first step is to identify who should receive training and what training is needed. Okay, so the three main group for training are users, managers, and also the IT staff. Okay, so you must determine how the company will provide the training. Okay, so there are many training platform that you can use currently. Okay, vendor training. Okay, and then webinar, podcast, and tutorial. Okay, so many vendors offer web-based training option. Okay, including webinar. Okay, web and seminar is an internet-based training session that provide an interactive experience. Okay, so they will have a pre-recorded webinar. Okay, and then outside training is, for example, like training consultant, institute, and firm. Okay, that provide the training packages. And then training tips. Okay, interactive training. Interactive training here, meaning that hands-on training. Okay, so it will be less expensive method. Okay, and then okay, the famous one, online training. Okay, online training should include step-by-step instruction for using the features of the system. So they should have the training material, okay, that resemble actual screen and task, okay, of a user daily works. And then video tutorial, okay. So the video tutorial here, okay, uh, video learning session, for example, for this textbook, okay, were initially created as classroom teaching tools, okay, and then will be edited, okay, will be polished, okay, and transformed into streaming video. Okay, so you can use many free software uh, in the Google, for example, okay, or maybe in your laptop, such as Windows snipping tool for image capture, Wisdom soft auto screen recorder for live motion video, and Windows sound recorder for audio narration. Okay, so once you have created uh, the video, you can import the material into the Windows Live Movie Maker. Okay, so there are step by step, okay, on creating the video tutorial. Okay, so for your final project, okay, you need to produce a video presentation, okay, on how to use the system. Okay, so you must starting from the introduction, explain your system, okay, explain what kind of problem before customer want you to develop the system, okay, how to use the system. So you need to have the step by step, okay. And then this one, sample video tutorial. Sample video tutorial, you need to include images, narration text, and notes to the video developer and narrator. Okay, so this one is example of the Camtasia Studio. Okay, you can use this one, okay, video editing tool that can produce professional quality training video. Okay, so next thing, data conversion. Okay, so data conversion, it is an important part of the system installation process. So you should develop a data conversion plan as early as possible. Okay, and then the conversion process should be tested, okay, when the test environment is developed. Okay, Here are the data conversion strategy. Okay, data conversion strategies. When a new system replaces an existing system, you should automate the data conversion process or in a standard format, okay, such as ASCII or ODBC. Okay, and then lastly, data conversion security and control. Okay, for you to maintain strict input control, for you to ensure that all system control measures are in place. Okay, okay, so lastly, I want all of you to briefly explain 3 types of testing performed during system implementation phase. And after that, write your full name and metric number. Okay, together with your answer in the comment section. Okay, so that's all for today.